Thank you, Brittany. Good morning and good evening to all of you, and welcome to the webinar for implementing and troubleshooting site-to-site VPN. For some of you who do not know me, my name is Rohit Pardasani, and I am a full-time instructor with INE. I have about 5 CCIEs, CCIE route switch, security, voice, collaboration, and service provider. So without wasting much time, we will quickly get into the site-to-site VPN. Now, for today's webinar, what we are going to be doing is we would be building a VPN, a site-to-site VPN using IKEv1. And we would do that between iOS XZ, so basically a router, and an ASA firewall. And we would also be kind of troubleshooting it. So when I'm actually showing you the implementation, I would also show you how to troubleshoot VPN issues. So I am kind of going to key in incorrect commands or incorrect parameters so that we can troubleshoot the VPN. All right, so this is going to be our topology that we would be using for building the VPN and troubleshooting the VPN. So I have one router on the left side, which is in BGP AS1, and that is peering with the ISP, an eBGP connection with the ISP, and there is an ASA on the right side. Obviously, this is not like a typical production design, but it kind of works for this webinar. I just wanted to keep it simple. So I have an ASA on the right side, and that is also peering with the ISP as an eBGP connection. On the LAN side of the router and the ASA, I have 2 routers. They are basically emulating as clients who need to connect with each other. And for the LAN side, I'm actually running OSPF, and OSPF, the default gateway router, which is the edge router, is basically sending a default information originate, so basically a default route. So my clients have a default route, they have an IP address, they can reach the default gateway at this point of time. However, I have not really redistributed OSPF in BGP because you would never do that in production. There would probably be some kind of NAT happening on the edge device. So, and then probably you would have VPN. So obviously if the clients need to connect to internet, there would definitely be some kind of NAT happening, which normally you would. And if you're just doing a site-to-site VPN, you don't really need to have NAT, but normally you would. So in my case, right now, I have not configured any NAT because it's only a site-to-site perspective, and I have not really configured NAT on ASA or on router 1. We could do that, but I haven't really done that right now. So what I'm going to be doing is I will start off with configuring the ASA and router 1 to build a site-to-site VPN. And I will configure router 1 correctly as per whatever desired encryption parameters we want, or authentication we want, or DEFI element group we want. I will build R1 completely correctly as per whatever requirements we want. But ASA, I will incorrectly configure the ASA. So, and then we will look at debugs. We will look at the debugs and kind of identify how can we quickly look at what's the problem. Is it a phase 1 problem? Is it a phase 2 problem? Maybe it's an interesting traffic problem. Maybe my crypto map is wrong. Maybe my policy attributes are wrong. So we will look at that in the debug. So, all right, so what I'm going to do is start off with the ASA configuration. I will start off with the ASA configuration, and I will show you the step-by-step configs that you need to build a site-to-site VPN. Now, if you look at VPN, things that you must always keep in mind. Like, I always consider VPN a 6-step process, a 6-step. Step number 1 is defining your phase 1 policy. So you have to basically negotiate with the remote peer saying, what attributes are we going to be using? Are we going to be using, let's say, authentication as pre-share, or are we using a certificate for authentication? So that's something that you need to discuss with the remote peer. So maybe with the remote engineer. So what's the authentication parameter? What encryption we would be using? What's the hashing algorithm? And def element group. So step 1 is creating the policy which contains these 4 attributes: authentication, encryption, hashing, and def element group. So that's your first step. Step number 2 would be to create the pre-shared key. So let's say if you were doing authentication as pre-share, then you need to define a predefined password. So that password has to be same between both the peers. So IKEv1 supports only symmetric passwords. You cannot use like an asymmetric password. IKEv2 does support asymmetric. So maybe if I was using IKEv2, I could have a password of Cisco and you could have a password of Juniper. So I could do that. But obviously we both need to know each other's password also. So you can do that with IKEv2, but with IKEv1, you can only have symmetric passwords. So basically agree on the password, like what's going to be the password. I will keep a simple password, which is going to be Cisco. Obviously, you should never do that in production. That's the first thing normally attackers would probably use. So yeah, I'm going to use Cisco. Then, so that's the thing that you negotiate with the remote peer, that, okay, what's the password we are going to use? What's the encryption we're going to use? And what's the hashing? What's the def element group? And then if you're using pre-share, what's the password going to be? If you're doing certificates, then step number 2 would be not creating the pre-share. Instead of creating the pre-share, you would go and register yourself to a CA server, obtain a certificate. So both the peers need to go and obtain a certificate from a CA server. The CA server could be an internal enterprise CA server, or it could be from the internet, so public CA. So it really depends on you. So in our case, we would keep it simple. We would have a pre-shared key defined, so a predefined password, which is going to be symmetric, and my password would be Cisco. So step 1 was creating an IKE policy. Step 2 was defining the password for the authentication or certificate, depending on what you're doing. Step number 3 would be defining how my data is going to be protected. So my IPsec transform set. So if you look at the VPNs, the VPN negotiation part, it's basically 2 parts, right? The first part is the IKE negotiation, that how should my tunnel be protected? And the part 2 is, or the phase 2 is IPsec, that how should my data be protected? So it's basically the negotiation part of the VPN is 2 parts, phase 1, phase 2. So when I said create 6 steps, the step 1 and step 2 is a part of phase 1. So where we were creating the IKE policy, we were creating the pre-shared key or the certificate, that's your phase 1 part. So step number 3 was the phase 2 part. How should my data be protected, which is creating a transform set. That's your step 3. Again, the transform set name is locally significant. It does not need to be the same. However, the attributes inside the transform set, that needs to match. So that's your step 3. Step 4 is defining what would trigger the VPN. So basically your interesting traffic. So you define your interesting traffic. That is defined using an access list. See the legacy VPN, the site-to-site VPN, the legacy method, which is the cryptomap method. I mean, it's surprising that a lot of people still use it, but it's not scalable. The only reason being is that accessless or interesting traffic can really become complex as your network grows, as your LAN segment requirement grows to connect to remote sites. So it's something that it's not scalable, but you'll be surprised that I still see in production like 70 to 80% still using the legacy crypto map. The whole point being is that if it's not broken, then don't fix it. You know, it's been running since years. So that's why you'll find this pretty much in 70% of the companies. So my step number 4 was the interesting traffic, creating the access list. And you must remember that the interesting traffic access list must be a mirrored image. So if I have an access list from me to you, you must have an access list from you to me. So it has to be a mirrored access list. That's your step number 4. Step number 5 is basically getting all your step 1 to step 4 into a container. See, the thing is that I cannot apply my transform set, which is step number 3, or my access list, which is step number 4, or my step 1 and 2. I cannot apply that directly to my interface. That which interface is going to be used to communicate for VPN with the remote peer. So I really cannot apply all these 4 steps onto an interface. So the only way to do that is to create a container. So something like route maps. What's a route map? Route map is just a container where we kind of match things, do things, and then apply the route map to an interface. So same thing here, a container would be a crypto map. So we create a crypto map where we call all my 4 steps inside that crypto map. That's my step number 5. And step number 6 would be applying the crypto map to the interface. So 6-step process. It's pretty straightforward. You don't really need to memorize the commands because you can always do a question mark on the iOS box and kind of know, okay, I need to do this. So the only thing to remember if you're ever doing VPNs, remember the 6 steps. Think about, what do I need? Because if you don't know what you need, there's no way you could even configure it because you don't know what to look for. So I would say you don't need to memorize the commands. You don't really need to memorize the commands. Memorize that, what do I need? 6 steps. So create a policy. So you should think about it. Okay, what do I need? I need 6 things. I need a policy. The attributes within the policy must be same. I need a predefined password or a certificate. I need an IPsec transform set. And then I need interesting traffic access list. I need a crypto map, and I need to apply this to interface. So basically, 6-step process. Just remember that. That's all you need. So what I'm going to do now is I will show you the commands. I will show you the 6-step commands on the ASA first. And I will build that correctly. I will build everything as per our requirements, and I will build router 1 incorrectly. So I'll configure router 1 incorrectly. Okay, and let's go to, in fact, let's do the other way around. Just to keep it a bit more interesting with the debugs, let's do it the other way around. I will configure router 1 correctly, and I'll configure the ASA incorrectly. So we'll get some messages from ASA in the debug on router 1. And then we can look at the debugs. So let's start with router 1's config. And if you see right now what's pre-configured, I have OSPF neighborship with the LAN segment, and I have BGP with the ISP, and I have reachability to the remote VPN peer. Now, the first thing that before you even start, you should have, the first thing that you should check, do I have connectivity between the 2 VPN peers? There's no point of of really doing VPN, it's not going to work if you don't have connectivity between the two endpoints. When I say connectivity, you kind of need ISACEM, so UDP 500 and ESP. So these are the only two things that you need. If you don't have NAT, if you have NAT, then you need UDP 4500 to be added. But so the first thing that you do is check, do you have reachability between the WAN IP of the ASA and the WAN IP of router 1. So do we have reachability? Yes, we do. So if I actually do a ping, I have already pre-configured that with BGP. So if I do a ping to 200.0.0.1, which is the ASA's IP address, the WAN IP, I have reachability. That's the first thing you check. So let's now build the VPN. What I'm going to do is start with the 6-step process. So step number 1 was creating the ISACEM or the IK policy. Now, commands are a bit different for IKEv1, for IKEv2. I'm not sure if this router supports IKEv2. We can just check it out. So it does support IKEv2, but if you look at the command-wise, it's pretty similar. So if you're doing IKEv2, you say IKEv2 policy or proposal, in fact. But if you're doing IKEv1, you would say ISACEM. So crypto ISACEM policy. Now the policy number does not need to match with the remote peer. It does not need to match. It can be any number. But there's a significance for this policy number. The lower the number, the better is the chance of it being sent first. So let's say if I have 3 policies, policy 1, 2, and 3. The key difference between IKEv1 and V2 was that in IKEv2, the entire proposal was sent together. So it's much faster. With IKEv1, it's like policy by policy. So it's going to send policy 1. If it doesn't match, then he will send policy 2, then policy 3, and then policy 4, and so on. So the lower number policy is sent first. So I'm just going to create one policy here because we are configuring router 1 correctly. I will go to ASA and configure everything incorrectly. So step number 1 was creating a policy. Let's just keep it as policy number 1. And here I will define 4 attributes. Authentication. I would define encryption, my hashing algorithm, and my defilement group. So let's do authentication as pre-share. I could do RSA signature and maybe go and register to a CA server. I could do that, but I'm not doing that at this point of time. So my authentication is going to be pre-share. Encryption is, so it kind of supports 3-DAS, AES, DAS. So DAS is 56-bit and 3-DAS is 3 times of that, so 168-bit. And then AES, we have 3 variants. We have the 128, 192, and 256. Now, see, if you're doing it between 2 routers, they kind of support the same attributes. Like they would support AES 128, or for hashing algorithm, they would support SHA-512. But let's say if you were doing between a router and ASA, make sure you go to the ASA and check what attributes it supports, because you may configure maybe SHA-512 and maybe the ASA does not really support SHA-512. I mean, it's kind of surprising that, okay, you know, it's a firewall and it's not supporting SHA-512. But ASA was never actually built for, I mean, traditionally, it was a firewall. It wasn't really for VPN. But yes, it does support IKEv1. It does support IKEv2, the 9.6 and above code. It does support IKEv2 also. So just kind of be careful about what attributes you use. Use something that the ASA supports. So I believe the ASA does not support SHA-512. So I'm not going to use that. But for encryption, I'll just use AES 256. And let's say for hashing, let's use SHA. So I have these options here. But if I actually go to my ASA, and let's say if I do a crypto IKEv1, so the command here is a bit different. but concept is the same. On routers, we say crypto ISACEM versus ASA, we say crypto IKEv1. Policy, let's say policy 1. If I look at my hashing, it only supports SHA-1 and MD5. So what I'm going to do is go to my router again. Let's just use SHA because ASA supports just that. And my DEFI element group, I could use any of these. Again, we have to see what ASA supports. I know the ASA supports 5, so we'll use 5. That's all I need. That's my step number 1. So let me quickly show you that. That's my step number 1, which is creating the policy. I have my authentication pre-share encryption. SHA-1 does not show up because that's default. And then I have group 5. So step number 1 is done. Step number 2, what was step number 2? It was defining the pre-share key, which was, because I'm doing pre-share, I have to define a pre-shared password. If my authentication was RSA signature, then I would go and register to a CA server. So this can be done in 2 ways. I could go and do a static key, which is done with the crypto ISACEM key command, and then say Cisco, and then the address of the remote peer. This is one way of doing it. Is this recommended? Kind of depends, but normally you would not do this. You would probably use the keyring, which is the second way of doing or defining the password. The advantage of defining the password through the keyring is that the keyring, we can define the source of the packet, which you cannot define with the ISACEM key. With the ISACEM key, depending on your routing table, whichever is the default outbound interface, it's going to use that as the source for your phase 1. But with ISACEM, with your keyring, I can also use the loopback for communication. So I can do that. The second advantage of using the keyring is that if your interface was not in the global table, let's say if it was maybe in a VRF. So if it was not in the global table, then this command, the ISACEM key command, that's only for global table. If your interface is in the global table, no problem. But if your interface is in a VRF, then you cannot do ISACEM key. You have to do keyring because that's the only way to define a key for that specific routing table, which is the VRF. So obviously, keyring is a better way of doing it. In my case, right now, I am in the global table, so it doesn't really matter. So I could do keyring, I could do static, doesn't matter. So my address is going to be the remote peer, which is the ASA's IP, 200.0.0.1, which is the ASA's IP. So step 2 is done. What was step 3? Think about step 3. Okay, step 3 was how my data should be protected, IPsec transform set. So that's going to be done with the command crypto IPsec transform set. And then the transform set name does not matter. You can use whatever you want. So let's say I use site to site. And then I define 2 things, encryption and hashing. So encryption is going to be done with ESP, and then I can choose whatever encryption I want. Again, you should go and check on the ASA because the parameters really change depending on the code of ASA you're running. So if you actually go to 9.2 or 9.1, it may support less things. If you go to 9.8, it may support more things. But IKEv2 has more encryption parameters than IKEv1. Obviously, everybody is now starting to move to IKEv2 for a lot of advantages of it being faster and more secure. But if you're using IKEv1, make sure you go to the ASA and check what parameters it supports. So let's go to define AES, and let's use 256 and say ESP SHA HMAC. So I'm not doing SHA 512, I'm just doing SHA HMAC. And my encryption is AES 256. So my step 3 is done. Now, what was step 4? defining the interesting traffic. What's my interesting traffic? If I look at this diagram, I have interesting traffic from 10.0.0.0/24 going to 192.168.10.0/24. That's my interesting traffic. Now, this LAN segment of both the sides, it's not reachable on the internet. That's something behind the edge router. It's not reachable, it's not advertised, it's a private network. So the only way for it to go from one segment to another segment or one branch office to another branch office is through VPN. If I want to go to internet, then yes, I could do NAT. So step number 4 is going to be defining the interesting traffic. Let's create an access list. I like using a named access list. You can use a numbered access list also. So let's say IP access list extended. Let's name this INST. And here, this is going to be permit IP 10.0.0.0.0000255 to 192.168.10.0.0000255. That's my access list. And step number 4 is done. What was step number 5? Calling all these 4 steps into a container, which was my crypto map. So that's going to be step number 5. So that's done with crypto map. And you can name it whatever you want. It's locally significant. And then I have sequence number. Again, the significance of the sequence number is, see, I may have one interface, one WAN interface, which has the crypto map applied, but I may want to go to different directions. I may have backup VPNs. I may have multiple branch offices that I want to go to. So I can have sequence number defined. Okay, try this one first. If not, then try this one, then this one, and then this one. I can define that. So I have sequence number. Right now, I just have one VPN peer. So it does not really matter what sequence number I define. Let's just give 1. And then we have Ipsec ISECM. So what am I doing in the crypto map? I am combining my step 1, which is ISECM, and my step 3, which was Ipsec. So all of that, all my 4 steps into this crypto map, into this container. So hit enter, and now I will call all my things inside that. So set peer. So this is basically calling my step 1 and 2. So set peer is 200.0.0.1. Then I will call my step number 3, set transform set as, I believe it was S-2-S, and then match address INST. That's all I need. My step 5 is done. Step 6 is applying the crypto map to interface. That's my step number 6. So let's go to my interface. I believe the interface is gig 00.12. So interface gig 00.12, and let's say crypto map VPN. So 6 steps done. I have 6 steps done. Next, I would go to my ASA and configure my ASA. But this time on the ASA, I will build everything incorrectly. All my 6 steps, I will do wrong. All my 6 steps, I would do wrong. So, or maybe 5 steps, applying crypto map, I would do that. So let's start with the ASA. Step number 1 was what? Creating a policy, right? Now, that's done with crypto IKEv1. The only reason I'm giving IKEv1 is because this ASA code supports IKEv1 and IKEv2. If you actually go to, I believe 9.1 or 9.2, I'm not sure. I think 9.2 did not support IKEv2, but, or maybe 9.4 did not support IKEv2. I think it was from 9.6. I'm not sure about that. But yeah, I think this one is running 9.61. So this one does support IKEv2. That's why the command is different. Otherwise, if you go to the old code, let's say 9.1, it would have the command crypto ISECM. But because this ASA supports both IKEv1 and IKEv2, the commands have changed. So you have to give crypto IKEv1 or IKEv2 and then policy. So I would say crypto IKEv1 policy, let's say 1. I'll make 3 policies here, or maybe 2 policies I'll make here. Let's say policy number 1. Policy number 1 will have authentication pre-share, encryption. I think we used AES 256 there. I will give an incorrect encryption here. Let's say 3DES. Okay, I'm using 3DES. And hashing SHA. So my hash is the correct as per policy 1 on the remote side, but my encryption is wrong. And Defi element group 5. Let's make another policy. Crypto IKEv1, policy number 2, authentication pre-share. This time I would give the correct encryption as AES 256. But my hashing, which was SHA, I would give that incorrect, MD5, group 5. So I'm just creating 2 policies. Both policies are wrong. The attributes are wrong. In policy number 1, encryption is wrong. Everything else is correct. In policy number 2, hashing is wrong. Everything else is correct. I'm not making a 3rd policy. So basically my phase 1 is going to fail. Now there's one tiny small step in ASA only, not on routers. So I'm not going to count that as the 7th step. It's basically the phase 1 or the IKE is disabled by default on ASA. So you have to enable that. On routers, you don't have to do that. So you just have to go and say crypto IKEv1 enable outside. So I'm going to keep this as not a step, something that you should remember, that it is disabled by default. So step 1 is done. Now I would do my step 2, which was defining the pre-share password. On the router, we did crypto ISACM key command, or we could do the keyring. On ASA, there's no keyring. We can only do the tunnel group command. The command is different, but concept is the same. So I would say tunnel group, give the remote peers IP. Because if you look at the command actually on the router, let's say show run section crypto. If you look at this command, what does it contain? It contains a password and it contains the peer address, correct? That's the same thing I'm doing here on ASA. So I'm defining the tunnel group by defining the peer address, which is 100.0.0. Let's say 1. And type would be IPsec LAN to LAN. So I've defined the peer. Now I will define the password. So which is done by saying tunnel group, the IP address of the peer, and IPsec attributes, where I would say IKEv1 pre-shared key, and I'll define my password. That's my step number 2. So the only difference is that on a router, I could just give one command, one line, crypto ISACM key command, but that command does not work on the ASA. It did work earlier when in, let's say 9.1, when there was only support for IKEv1. But in the new code, that command doesn't exist. So you have to give the tunnel group command. So tunnel group, define the peer's address, and type would be IPsec LAN to LAN. And then under the IPsec attributes of the tunnel, you define your pre-shared key. So I will go and give a wrong password here. Let's say I give Cisco 1. So my step 2 is also incorrect. What was step 3? Transform set. Let's do that, crypto IPsec. So if you look at the command on routers, it was crypto IPsec transform set. This command doesn't exist because you have to give the command crypto IPsec IKEv1 transform set. So I really don't know why Cisco does that. Like commands, they keep it different. I guess it's different BU. So that's why, because most of the products Cisco acquires. So that's why probably the commands are different. But it would be nice if, you know, all products had the same kind of commands, so it would be easier. But yeah, I mean, concept is the same. So crypto IPsec IKEv1 and transform set. And let's name the same S2S. It doesn't need to be the same. It could be different. It's locally significant. And let's define ESP. So I will give my transform set incorrect. I think we use AES 256 on the remote side. So let's give 3DES and ESP SHA HMAC. So my encryption is wrong in phase 2. So even phase 2 is going to fail. Step 4 was defining the interesting traffic. Let's create the access list. So access list, let's say INST. This should be a mirrored image. So the thing is that there are cases where it kind of works without even being mirrored. But the only problem is that, let's say if I give a single IP here, that IP would be able to do the VPN, but the remaining IPs would basically fail. So it's always like advisable as per Cisco docs that it should be mirrored. But I've seen cases where we don't kind of mirror. So permit IP, this should be reverse. So 192.168.10.0. And the key difference here in the access list on ASA is that it is not using wildcard mask, it's using subnet mask. Again, ASA router thing. So 255.255.255.0 to 10.0.0.0, 255.255.255.0. So step number 4 done. What was step 5? Calling all of this inside a container, which is CryptoMap. So that's going to be done with CryptoMap. Let's name this VPN, sequence number, let's say 1. And here I would say set peer 100.0.0.1. That's my first thing inside the container. The next thing was set IKEv1 transform set S to S. And third thing was the interesting traffic. So match address INST. So, okay. And so, yeah, I mean, I've actually given the step 4 also correct. I have given the step 4 correct, but maybe I won't apply my CryptoMap. Let's not apply that. So maybe I forget my interesting traffic. So step 4 is wrong, step 5 is maybe wrong. And lastly, step 6 was applying the CryptoMap to the interface. So let's go and say CryptoMap VPN interface outside. So it gives me a warning that my CryptoMap is incomplete, which is a good thing, because now I can just do a show run CryptoMap and see that, okay, in fact, this version, so the good part about IKEv2 is that it actually shows you that what's missing, but this one really does not. But it just gives me a warning that, hey, your CryptoMap has something incomplete, so you should be able to look at it and maybe find out what the problem is. But we'll look at debugs and see what the problem is. So let's go to my client, router 1, and let's start debug. Obviously, my VPN is going to fail. I know it's going to fail. Let's do a debug crypto IKEv. Okay, and let's go to router 1 or client 1 and do a ping to, so client 1 is behind router 1 and client 2 is behind ASA. So I would ping client 2, which is 192.168.10 dot, I believe it's 2, and let's hit enter. So I get an unreachable message, but that's okay. Let's go to router 1, and I don't really see a debug. I don't see anything. So what could be the problem? What's the first thing that how I would troubleshoot? How would I, let's say if I was troubleshooting this, how would I look at this? So the first thing that I would do, I mean, you should not do a debug crypto IKEv, or because that gives you a lot of message. And imagine if you have like 20 or 30 or 50 VPNs, that's going to give you a crazy amount of messages. So normally I would do like a conditional debug to a peer. So it only gives me messages of that peer. But right now we just have one peer, so it doesn't matter. You can just do a debug crypto IKEv. And what's the first thing that I would think of? Okay, I did a ping what did I get back? First of all, I got unreachable message. That's the first thing I got, which means somewhere there's a routing issue. The second thing that I got is that I never saw a debug. I never saw anything in my debug messages. So it basically means that it probably did not trigger, nothing triggered. That's what it means. It means that nothing triggered, which is not a good sign. So this kind of indicates it's a routing issue. You know why? Because if you look at the packet, where's the packet coming from? It is coming from here, unencrypted, going to router 1. Router 1 does a routing lookup before it reaches the VPN endpoint. So my tunnel actually starts from here. It actually starts from here, right? So the packet has to reach this interface, only then that's where the crypto map is applied. That's where it'll go inside the tunnel. But the packet never reached that interface. That's why I don't see any debugs. I didn't see any debugs because the packet never reached the outbound interface. So the first thing that I would think of, okay, why would I not get a debug? The first reason could be, maybe I don't have a route. Maybe I don't have a route to internet. Because at the end of the day, router 1 is still going to do a route lookup to the LAN segment of the remote side. I just need to point it to the tunnel. So when the packet comes to router 1, he does a routing lookup before sending it to the VPN tunnel interface. And when he does a route lookup, he does not have routes to 192.168.10.0. So he would just drop the packet. And I don't have a default route to internet also. So ISP is not really sending me any default route. So how do I fix this? Maybe I have a default static route to the ISP. Maybe I have that. Let's do that. Let's go back to router 1. See, always break up your troubleshooting. Don't, like, I've seen a lot of people, like, they start looking at configs. I have never actually looked at configs to troubleshoot at least VPNs because it takes more time. I mean, let's say if you do have time, yeah, it's nice to look at configs and see what the problem could be. But let's say if you were in a CCIE lab exam, you're limited by time. There's no way you can look at so much of configs and see, okay, what the problem is. That's just basically memorizing. It would not help you in production. So a good way to troubleshoot is definitely using debugs. Obviously, you should do debugs at a specific time, depending on your maybe a downtime, or maybe you've taken some permissions. You just shouldn't do it live because it may cause CPU usage. So let me go and just put a default route. So I don't have any routes. If you look at my routing table, there's no route to 192. So all I'm going to do is put a static route to the ISP. And I think my next hop is 100.0.0.2. So now I have a default route. Let's go back to the client. I believe my debug is still turned on. Let's go back to my client and do a ping. So this time I see drops, which is better than unreachable. So now I go back to my router, and what's the thing? What question would I ask myself? The first question I would ask myself, do I see debugs? If I don't see debugs, 3 things you would check. 3 things. First, routing. Maybe you don't have routes to the tunnel interface to that remote LAN network. So the first thing you would check if you don't see debugs is check your routing. Second, if routing is okay and you still don't see debugs, like debug outputs, then the second thing that you would check is maybe the crypto map is not applied to the interface, the outbound interface. Because if it's not applied, why would I see debugs? That's the second thing I would check. And let's say if that was okay, then the third thing I would check is maybe my interesting traffic access list is wrong. I don't care about phase 1, phase 2. I don't care about that at this point of time. What I care about is, do I see debugs? That's what I care about. So 3 questions you should ask yourself, or 3 things that you should think of for the first question. Do I see debugs? If not, check routing, check crypto map is applied to interface, or check if the interesting traffic is correct. Because if interesting traffic is incorrect, it won't trigger the VPN request. So I know I see debugs, so I know that those three things are okay. Routing is okay now, crypto map is applied, and access list is okay. Now I will look at my debug output. Let's see what we get. So what do I see? I see that a new peer was created, and I see IKE deleted. So no state. So main mode, no state. main mode, no state indicates it's a step 1 problem. Step 1. Because if you look at the whole process of IKE, it actually does the negotiation first and then the authentication starts. So my authentication starts after the negotiation has been done for that, do we match on the attributes? So no state basically indicates that, hey, my step 1 itself failed. Let's go to the ASA also and do a debug just to see if we get some more information there. Let's do a debug crypto IKEv1. Let's do 9. So 9 is a bit more detailed. And let's go to client 1 again, and let's try the ping. Ping doesn't work. I look at the ASA, and what do I see? It says all SA proposals were found unacceptable. So my step 1 was the problem. Everything was not matching. So that's kind of my issue. Again, 2 ways to identify this is no state, or on the ASA, we see that my security association for IKEv1, they all were unacceptable. So that kind of tells me that, hey, it's a step 1 problem. I won't even look at my password. There's no point. So let's say if I was troubleshooting this, I would not go and ask my remote engineer saying, hey, what password have you used for authentication? There's no point asking him that because the authentication does not even start. My step 1 has failed. So the only question I would ask him, what's your attributes for phase 1? So he would tell me, okay, I'm using authentication pre-share, I'm using group 5, SHA-1, and AES-256. So that's what I would do for identifying, is it a step 1 problem? Let's go and rectify that now. So I would go and create another policy, show run crypto. Let's make a policy number 3. So on my router side, I only have one policy, policy 1. The number does not matter, the attributes matter. So here I would say authentication, let's just copy it. Authentication, pre-share, encryption AES-256, and hash would be SHA, and group would be 5. So now my attributes match. Okay, let's go back to router 1, or my client 1, and do a ping. And let's look at the debug. What do I see? So can you see here? Let this finish off. I'll show it to you. I mean, I have kind of the eye to just look at it while it's moving on because I'm just used to it. But if you keep doing this, you'll get used to it too. So let's go back up and look at where it starts from. Let me do an unall. It'll keep coming. Because it tries 5 times. So if I look back at my debug from where it started, here you go. Okay. So it started from, this was the old one, I guess. No state. And here you go. So look at this. So the remote peer sent me the policy. So what's going to happen? Because I triggered, router 1 triggered, so he sends a request, hey, I need to form a VPN with you. Give me all your attributes for phase 1 negotiation. So the ASA is basically sending the list of attributes. It basically matches, and I can see attributes are acceptable. So now I know my step 1 is okay. If I look back at the ASA and scroll back up, I should see the same thing here, that, okay, the proposal acceptable, matches the IKE entry, and my proposal was acceptable. So now they both step 1 matches, so absolutely no problem. Only if my step 1 is correct, only if it matches, it moves on to step 2, which was authentication. So if I look back now on router 1 and see here, after the attributes were acceptable, it will now start the key exchange, which you would see here, authentication. Authentication has started, the pre-share key. And I would see it's stuck at this phase. It says key exchange, attempt 2, attempt 1. It'll try 5 times. The reason you get this message is key exchange. It kind of indicates, hey, it's a step 2 problem. So if I ever see that key exchange, main mode key exchange error, I would not ask the remote engineer about what's your phase 1 policy, because this process would only start if step 1 was successful. So there's no point of me asking him that question, because I know that if this process has started, it means that step 1 was okay. So I would ask him now, hey, what password are we using for our authentication? Are we doing pre-share? Are we doing certificate? So either you would see an key exchange, or you would see a certificate mismatch, depending on what authentication method you're doing. So now I know with this, it's a password problem. Let's look at the ASA. Do we see anything about authentication? So connecting on this tunnel, and yeah, mismatch pre-share key, aborting. You see how simple it is if you know what to look for. So I see a mismatch pre-share key. So step 2 problem. I won't look at step 1 anymore, because authentication process only starts if step 1 was success. So now I would go and rectify this. Let's go and do a show run tunnel group, go to my pre-shared key, and change this to Cisco. So now my step 2 is okay. Let's now go and do a ping again. Let me do a debug again, debug crypto ISACM, and do my ping again. I don't care of the ping. I don't care if the ping works or not at this point of time. What I would do is look at my debug. And how do I know if step 1 and step 2 is okay? If step 1 and step 2 is okay, you will see this message here, which is phase 1 complete. So this message, phase 1 complete, only comes if your step 1 and step 2, they both are a success. Only then you would see phase 1 complete. And your tunnel is up. So if I do a show crypto ISACM SA, you will see your tunnel is going to be up. Let me go into on all. Show crypto ISACM SA. So I should see a QM idle. Let's give it some time. Let's go back to ASA and see if I see phase 1 complete here also. So what do I see here? Phase 1 completed. So now I know that my step 1 and step 2 is okay. No problem there. Now, only after step 2 or phase 1 is complete, which means step 1 and step 2 is success, only then step 3 starts. What was step 3? IPsec negotiation, which was your transform set negotiation. So step 3, which is your phase 2, only begins if phase 1 is completed. So if I ever see a phase 1 complete, I will not ask the remote guy, what's your phase 1 attributes? What's your password? I don't care about that. That's okay. I would just look at IPsec. So we look at step 3. Is step 3 a problem? We should be able to see it here in our debug. Let's scroll back up. It should say after the authentication, so attributes were acceptable. And then we should have authentication happening, which is here. So it has been authenticated. So I know step 2 is okay. And phase 1 was complete. Beginning quick mode. That's your cue for IPsec negotiation. So quick mode only begins, or IPsec negotiation only begins if phase 1 is complete, which means step 1 and step 2 has to be complete. And here you would see that my attributes are not matching. So I believe I turned it off. So yeah, I think I turned my debugs off. Let's go back and do a debug crypto IPsec or ISECM SA. And let's go back and ping. Back at router 1. What I'm looking for is beginning quick mode. So here I know authentication was success and quick mode has begun. And I see that IPsec is being deleted. So again, a quick way to identify this is you can go and do one command. Let's do an unall. You can do a show crypto IPsec SA. So in the crypto IPsec SA, I think I did unall. So in the IPsec SA, if you do, you see this inbound ESP and outbound ESP. It's blank. What should be inside that is your transform set. So your transform set should be inside the IPsec transform set. This indicates that it's a step 3, which is your phase 2 problem. But the only way I would reach here is I would first see what I should do, what you should do, take the debug into a notepad and just do a control F, search for phase 1 keyword. If I see phase 1 complete, don't even look at step 1, step 2. Then search for phase 2 complete. If you don't see phase 2 complete, you know it's an IPsec problem, step 3 problem. Another way is just do a show crypto IPsec SA. You should have your transform set inside this. It's not there, so I know it's a step 3 problem. Let's go and rectify that. So show run crypto IPsec transform set. Let's change this to, I believe it was AES, ESP, AES 256. So now I've changed my transform set. So if you see now my transform set matches. Let's go back and do a debug crypto ISECM and just do a ping. Ping doesn't work, that's not a problem. I don't care about that. What I care about is my VPN tunnel up, is my IPsec negotiation success. So let's go back here. So I see authentication was success. Quick mode should begin. Beginning quick mode is here. And what else do I see? So I don't really see a phase 2 complete yet. I see it's acceptable, but I don't see a phase 2 complete. Let's look at the ASA. It says that the session is being toned down and it's being deleted. Do we see any other message? I see phase 1 complete. I don't see anything about phase 2. Now again, your phase 2 could be affected with your ASA crypto map being incomplete. So your negotiation, because the access, interesting traffic access is not applied on ASA, it's really not going to match or negotiate how my data is going to be protected. It's not going to do that. And if I look at show crypto, let's say IKEv1 SA, there's nothing. So let me go back to my crypto map and do match address INST. So now I have that too. Let's go back and do a ping. Let's look at our debug. I see a phase 1. I see dead peer detection. Are you there? So this was my, I believe, my whole config. Let's do an unall. Show run crypto. This was my phase step 1, show run crypto. And then I had my IPsec transform set, S to S. I had my peer. I had my interesting traffic and interface outside. So config looks okay. Let's go and check by doing a show crypto IPsec SA. Let's see. Now, if you look at my inbound ESP, I see the transform set. So I know my phase 2 was success. I know it was a success, phase 2. If I look back at ASA, show crypto IPsec SA, I see it here also, IPsec SA. And if I go back to router 1 and do a show crypto ISECemp SA, I see QM idle. So my tunnel is up. My phase 2 negotiation was success, but my ping does not work. My ping is not working. Okay, my VPN is up. So how would I identify now this problem? How do I identify, maybe it's a routing issue, maybe it's some other issue. Let me go and do an unall first. I will show you a quick way to identify once you see phase 2 complete. So this method that I'm going to show you right now, you should only do that after your phase 2 is complete. So after your IPsec is up, which means your tunnel is up and your data is being protected, but your data is still getting dropped. So if I look at the ping doesn't work. Let's go to router 1. And I know my VPN is up, which I can see. And if I go to IPsec SA, which is my data, if I look at my IPsec SA, what do I see here? 9 packets got encapsulated, and 9 packets were encapsulated and 9 packets were encrypted, but I see no decryption, no decaps. What does that really mean? Just give me a minute. There's sun coming on my eye. Okay. All right. Yeah, it was just directly on my eye. So I don't see any decap. So this indicates that router 1, send the packet encapsulated to the remote peer. Did the remote peer receive it? If I do a show crypto IPsec essay, I see decaps, which indicates what? One way from router 1 to ASA, the packets were received. He de-encapsulated the packets or decapsulated the packets, and then he forwarded the packet to the client. However, the reverse traffic is not going because he's not encapsulating. So a quick way to identify routing issues is if you ever see incap incrementing, but decap not incrementing, it indicates it's a remote peer's routing issue. It indicates it's a remote peer's routing issue. And to confirm that, on the remote peer, if the decap increments and the incap does not increment. If the incap does not increment, it's a local routing issue. ASA has a routing issue. And how do you identify if there was a fire? Let's say if there was a firewall in the middle. Maybe this was not an ASA, this was a router, and maybe there was an ASA in the middle. In that case, on one of the router, you would see incap and decap, both incrementing, no problem. But on the remote side, you would see maybe decap not incrementing, but incap happening. So if that's the case, then you should know, okay, there's a firewall somewhere in the middle which is blocking my ESP packets. That's a quick way to identify that. So if my side, incap, decap increments, no problem. Remote side, decap does not increment, but incap is incrementing. Indicates that there's a firewall which is blocking ESP coming in. Quick way to identify. But on my side, incap increments, but decap does not, indicates you have a routing issue. And on your side, if incap does not increment, you have a routing issue. So I know from this, ASA has some kind of routing issue. Let's check by doing a show route. I don't have a route back to the 10 network. So what's happening is the packet is coming from here. It is coming from here, unencrypted, gets encrypted or encapsulated, goes inside the tunnel, reaches here, gets de-encapsulated or decapsulated, and then unencrypted traffic goes here. Now reverse traffic, unencrypted traffic comes back here. ASA does a routing lookup. He doesn't have routes to go back to 10 networks. So he drops the frame before it goes to the tunnel. So that's your local routing issue. Let's go and fix that. So let's do a route outside 00 to 200.0.02, which is my ISP. So now I have a route 2. Let's go back and ping. This time my ping works. And the packets are encrypted. You would see I have decap also. So incap and decap, they both are working. So it's very easy to identify issues, like to pinpoint at what the problem is, as long as you know how to look at the debugs. So I'll quickly give you a recap of how to look at it. First thing is that take the debug. The first question should be, do I see a debug? If not, it's either a routing issue or it's a crypto map not applied or an interesting traffic issue. Once you see the debug, take the debug in a notepad. Search for phase 1, the keyword is phase 1. If you see phase 1, step 1, step 2 is okay. Then search for phase 2 complete. If you see phase 2 complete, your VPN is okay. So I don't even need to look at my VPN configs. So if you see phase 2 complete and your ping does not work, then don't look at your VPN config. It's some other issue. It could be a firewall in the middle, or it could be routing issues between the two peers. But if I see phase 1 complete, but I don't see phase 2 complete, then I know that, okay, step 1, step 2 is okay, but IPsec is an issue. And if I don't see phase 1 complete, I would either see key exchange problem, or I would see certificate problem, or I would see no state, which is phase 1 problem, step 1 problem. So search for the keywords and you can fix things like this in less than 2 or 3 minutes. See, remember in the CCIE lab exam, it's not that you build the whole thing. I mean, yeah, there are questions where you have to build the whole thing from scratch, which will come by practice. If you keep practicing it like 10 times, it will become muscle memory. But you do get questions which kind of want you to troubleshoot. So it's pre-configured incorrectly, and you really have to do it fast because you're fighting against time in the lab exam. So the faster you do it, it's better than to look at running config, because your config can be really big in the lab exam. By the time you reach VPN section, which is maybe, let's say, section 2 or section 3, you've already configured so much on the routers or on the ASA that if you do a show run and look at that, it's going to take you much more. Yeah, you will be able to figure it out, but it's going to take you like 20 minutes. Instead of you looking at the debug, which you can fix things in like 2 or 3 minutes. It's super fast. You just have to know how to look at it. A quick way I would say how to practice this is in a pair. Like, let's say if you and me were practicing together as friends, let's say we are friends and we practice together, we are studying together for the lab. What I would do is first learn how to build from scratch, build it from scratch. And then walk away for maybe coffee or something and ask your friend to break it. And then you try looking at debugs to quickly identify yourself and give yourself 5 minutes. I should be able to identify in 5 minutes without looking at running config. That's how you can practice. And if you keep doing that, maybe in like 10, 15 times, you will get really good and fast at solving VPN problems. So that's it. So I hope you guys enjoyed the webinar. I will now answer some questions that I see. Let me go back to the first question. So I see a question here, would the PowerPoint slides be available? I mean, I didn't really use PowerPoint slides, so the video would be available. I think you should get an email with the video content, and it's probably going to be on YouTube and Facebook also. I see a next question. Any of the peers can be DHCP, right? In the case that can be DHCP IP, be private IP. So if you're talking about DHCP from perspective of the client side, yeah, they could be DHCP, doesn't matter. Then I see another question. DHCP for the tunnel. So if you're talking about DHCP from the tunnel perspective, then as long as you give him like a static IP through DHCP, then it's fine, because you don't want your peer IP changing every day. Otherwise, you'll keep going to your peer and defining the peer IP. Unless maybe you use like a DNS resolution kind of thing, then, but again, even if you use DNS, it's going to convert that to an IP. So even if you're using DHCP, as long as you give your VPN endpoint static IP through DHCP, then it's fine. I see another question, which I believe is 2 questions asked separately. When using certificate authentication, does the 2 certificate should be the same? I mean, share with the remote peer. So I believe what you're asking is that if you're using certificate for authentication, what needs to be the same is the CS server. So they both need to trust the CS server. So they need to have the CS server certificate installed. And then they need to have a unique certificate for each other from that CS server. So because the CS server is trusted, they would trust each other. I see another question. If we are using IPsec site-to-site VPN over L3 MPLS on firepower, whether our traffic throughput can be reduced or not. Are you asking that your throughput would be reduced or you want to reduce it? I'm not really understanding the question, but if you can email me with your proper question, I can respond back to that. Then I see another question. Let me know the difference between IKEv1 and IKEv2, which is more better. So obviously IKEv2 is better. It's newer, it's better than IKEv1. The only reason being is that it supports more attributes, it's asymmetric, and dead peer detection is built in. Like if you look at your phase 1, phase 2 steps, it's much faster. The negotiation is much faster. So obviously people are moving towards IKEv2. Then I see a question. Is it not necessary to, is it not necessary to have the no NAT feature in order to get real IP in the VPN LAN to LAN? So I didn't really do NAT. If we had done NAT, then let's say if my VPN endpoint was router 1 and ASA is doing NAT, the only thing I need to exclude in the NAT is the interesting traffic, because NAT happens before encryption. So I would need to exclude my interesting traffic from on the ASA to not get translated. Otherwise, it won't match my interesting traffic. I see another question. Wasn't routing not done for LAN to LAN? So routing was done for LAN, for within the LAN, which was OSPF, but I had not done routing as a default route from peer-to-peer. So there was no route to internet. They could reach each other through BGP, but they could not reach the internet. So there was no route from on the peer routers from to the remote LAN segment. There was no route for that. That's why I put a static route. I could have gone to the ISP and just send a default route. I could have done that also. Okay. I see an interesting question, which is, how about troubleshooting steps are the same from ASA VPN towards other vendors like Palo Alto? On the ASA side, it is the same. But obviously on the other side, the Palo Alto side or FortiGate or Juniper, it's going to be different. So in the Palo Alto, you can use the GUI to kind of troubleshoot, but you could use the CLI also, but you can use the GUI also. But on the ASA side, it's going to be the same. Then I see another question. If you have many VPNs, how do we differentiate debugs? So you have to do a conditional debug. So you can do a debug crypto condition and define the peer's address. So basically you're doing a conditional debug, not just doing a debug crypto ISACM, because that will show you hundreds of VPNs debug. So you should do a conditional debug. Then I see another question. Last time I did not receive BGP webinar. So will the same happen with this session? I'm not sure what happened with the BGP webinar, but if you probably contact, or just send me an email, I can direct you to the right person and they can send you a link to the BGP webinar. Okay. I see another question. Can we make a mistake in the ACL on one side to see the log? Yes. So if you make a mistake on the ACL, then obviously the ping is not going to work because your encryption is not going to match. So a quick way to identify that would be that you would not see debugs on your router because it doesn't match the interesting traffic. Okay, and why is the tunnel group command on ASA as a word and not an IP? It's actually, you can give an IP, but I think that's just the way it is. So Cisco's always been consistent in being inconsistent. So I see another question. NAT exempt can also cause incap 0 and decap increment at peer side. So yes, so if your NAT does not, it's not, let's say if you have not done, let's say if you have implemented NAT, but you have not exempted your LAN traffic to the remote LAN traffic in the NAT, then your incap will not increment. So that can also be an issue which can tell you, okay, you know what, routing is okay, but maybe NAT is the issue. But a quick way to identify NAT issues is you can do a packet tracer, or you could do logging on and just take the logs. It actually tells you that that this packet was exempted or not. But packet tracer is a great tool for on the ASA to identify even VPN issues with respect to NAT. Okay, so I'm going to answer one last question, and if anybody else is left out, then I believe I would receive the email and I would respond back. So I see a question. Is it safe to turn on debugs in ASA firewall currently running on a production environment? Debug crypto ISACM? No. Like heavy debugs? No. Again, that depends on how much traffic is flowing, what's your CPU utilization, what's your throughput. It all depends on that. So I would recommend doing it in a time that you've taken, like an off time, or but if you do like a small debug, like a conditional debug, it's still okay. It's okay to do a conditional debug. But again, that depends on what's your CPU. If your CPU is like at 95%, then don't even try debugs. All right. So I hope you guys enjoyed the webinar, and I will see you in my next one.